Good morning, students. Our today's topic is electric field lines and their properties. In the previous video, we have discussed about electric field and their strength. So, we know that an electric field is exist around a charge, and in this field if some charge is placed it experiences a force of attraction or repulsion. So charge tries to move towards the source charge or away from the charge, and the path through which charge moves is called electric field line of that source charge. Okay, so electric field lines are the path. These are the paths along which a unit positive test charge a unit positive test charge tends to move tends to move in an electric field if it is free to do so. Okay, suppose we have a positive charge and we place another positive charge at here, so it is travel along this line due to force of repulsion. So this is a line known as electric field line. Okay, basically the electric field line is also gives the direction of field. So we also define electric field lines are the path which is straight or curve. Here the electric field lines is a straight line but it may be curve, straight or curve, such that tangent to that curve at any point gives the direction of electric field. Electric field, or we can say electric field intensity at that point. Okay, so now if we have a positive charge, then in the previous video we have derived the direction of electric field as above. Okay, like this we represented that electric field line, or we can say electric field is normally outward from the positive charge. Similarly, if we have a negative charge like that, then electric field is in inward direction like this. Okay, or we can say these are the electric field lines due to positive and negative charges which are placed discretely or separately isolated charge. Now if the charges are not isolated, it means in a system there are say two charges. First of all, we consider a positive charge and a negative charge separated by a small distance between them. Then we know that electric field lines are normally outward from the positive charge and it is normally inward to the negative charge. So electric field lines are in this direction. Okay. The next, if we draw the normal line like this, and these lines are attracted towards the negative charge, we can say it forms a pattern like this. Okay, like this. We observe that the electric field lines forming a pattern like this. As these lines are perpendicular outward, so we represent it by the arrow, and similar here the electric field lines are perpendicularly inward like this. Okay, in case two similar charges separated by a certain distance, let we consider two similar positive charges certain distance, then the electric field lines, because the two charges are repelled with each other, and hence there is a force of repulsion, and hence there is a repulsion of electric field line also, like this. They can never meet each other, they repel from each other in a certain way, like this. As the electric field is normally outward, so we draw with these arrows. Okay, so this is the pattern of electric field lines due to a system of two similar charges. As we know that there is no electric field at this point, say it is the midway point of the two charges, say point P. So at point P there is zero electric field, so known as a neutral point. Okay, if the charges are equal and similar, means equal in magnitude and similar in nature, then this neutral point is exist at exactly at midway of the two charges. If one charge is small and other is large, then this neutral point is shifted towards a smaller charge. Okay, so basically we know from this article that electric field is represented with the help of electric field lines. Okay, so that's all about electric field lines. Now there are certain properties of the electric field lines, and these properties are, say, first one is electric field lines electric field lines are continuous curve are continuous curve. They started at positive charge and ended at negative ended at negative charge. What is the meaning of continuous curve? It is clear from the diagram that if a charge is placed near another charge, then it experiences a force of attraction or repulsion continuously. There is no jumping of the test charge from one place to another. That is why we can say this electric field is continuous, or we can say electric field lines are continuous curve. Okay, Second is the second property is that tangent to that point, yeah, tangent at any point of field line gives the direction of electric field. As it is discussed earlier, that consider there is an electric field line, say in this system there is electric field line. If we want to calculate the electric field intensity at point P, then the tangent at this point, like in this direction, so this direction represents the direction of electric field intensity at this point. Now at some other point, say here, if we draw the tangent, then it is in this direction, so the direction of electric field is along the tangent in this direction at this point, say Q. Okay, so tangent at the electric field line at any point gives the direction of electric field intensity at that point. So third one is no two electric line of force, or field lines are the same. Electric line of force can never intersect with each other. Okay, this is because if we consider two electric line of force like in this direction, or say it is the second line, so they intersect at point P. If we draw a tangent on this curve, then this must be in the direction of, say, this, and if we draw the tangent on the second line, then it comes in the direction of this. So at the point of intersection there is two direction of electric field, say it is one and it is second, but at a single point there will be no direction of electric field possible, so no two electric lines can intersect with each other. The next point is the two electric line of force are always perpendicularly outward from the surface, as we discussed earlier. Okay, the lines are perpendicularly outward from the surface. Next one is the electric field lines are contract longitudinally on account of attraction between two unlike charges, like in this system. Okay, if we consider a system of two unlike charges, then along the length the electric field lines are contract with each other so that they form a strong electric field near the charge. Okay, the next property is field lines exert a lateral pressure on account of repulsion in case of two like charges, like here. If we have two similar charges, then these electric field lines exert a pressure on this line so that they repel with each other. Okay, that is why we can say there is a lateral pressure on the field lines, because the two charges are repel with each other. So that's all about the properties of electric field lines. So thank you very much.